Hello, welcome everyone to this video. So today we are about to learn and solve another problem sets of structural analysis by Rusell C. Hibbeler of 10th edition and also Aslam Kassimali 4th edition. So I am Lavinia Efenyeza and this is my report. Problem 6.19, we have the FBD. So solution, P is equal to 3K over Ft times 20. So it is equal to 60K. The summation of moment of A is equal to 0. Summation of moment A is equal to By times 20 minus 60 times 10. So our By is equal to 30K. So the summation of moment of forces Y is equal to 0. Ay plus 30 minus 60 is equal to 0. Our Ay now is equal to 30K. So A is equal to 1/2 times 10 times 30. So our M max is equal to 150K per feet. So our max is equal to AM. It is equal to I over EI, 2 over 3 times 150 times 10 times 50 over 8. So the result of this is 6,250 K feet cube over EI. So our max is equal to L over 360. So 6,250, the L is times 12 cube over 29,000 I. So it is equal to 20 times 12 over 360, from which I is equal to 559 inch to the 4. Problem 7.10. We have a table here. So the summation of M moment B is equal to 0. Is it equal to negative 3ay minus 100 times 4 plus 50 times 3 is equal to 0. Ay is equal to negative 83.33 or 83.33 down. The summation of moment of y forces is equal to 0. So negative 83.33 minus 50 plus by is equal to 0. By is equal to 183.33. Summation of moment of B is equal to 0. Negative a of x times 4 minus 100 times 4 is equal to 0. A of x is equal to negative 100 or 100. The summation of Fy is equal to 0. Negative 50 minus 83.33 plus the AD over 4 over 5 is equal to 0. So our AD is equal to 166.67. So at FB, we have, as you can see the table, the FB, the summation of moment of B is equal to 0. Negative AY times 3 minus 1 times 4 is equal to 0. Negative 3ay over negative 3 is equal to 4 over negative 3. It is equal to negative 1.33. So the summation of forces of x is equal to 0. A of x plus 1 is equal to 0. Ax is equal to negative 1. Summation of y forces equal to 0. Negative 1.33 plus by is equal to 0. By is equal to 1.33 up. So 1 kn is equal to 2,367 kn squared m over EA. Then D is equal to 2,367 kn m over EA. So it is equal to 2,367 over the EA, which is the 70 times 10 to the power of 6A. So the answer is equal to 0.01 m, from which A is equal to 0.003381 m squared. We convert this to millimeter. and we can get the answer that 3,381 millimeters squared. For problem 7.37, we have also the table here. So solution. Summation of MA is equal to 0 minus 8RC plus 150 times 1.5 plus 20 times 5 times 3 plus 2.5 is equal to 0. RRC is equal to 96.875 kN. Summation of forces Y is equal to 0. RA minus 150 minus 20 times 5 plus 96.875 is equal to 0. RA is equal to 153.125 kN. For RAV, it is equal to 153.125, 3 over 5. It is equal to 91.875 kN. RAH is equal to 153.125, 4 over 5 is equal to 122.5 km. Summation of moment E is equal to 0. Negative 91.875 x minus MAD is equal to 0. MAD is equal to 91.875 x. Summation of moment of E is equal to 0. Negative MBC plus 96.875 x minus 20 times x squared over 2. Negative MBC is equal to negative 96.875 times 875x plus 10x squared. So our MBC is equal to 96.875x minus 10x squared. Summation of moment of E is equal to 0. MDB minus 91.875 times 91.875x plus 90 times x minus 25 is equal to 0. MDB is equal to 1.875x plus 225. 2kn B is equal to 1 over EI. So, as we can see here, the answer of B is equal to 1923.83 over 200 times 500. It is equal to 0.0192 m, and convert natin sa millimeter, 19.2 millimeter down. 0.5. Determine the equation of elastic curve for the beam using the x coordinate that is valid for 0 less than x and less than L. So the EI is constant. So we have here EI d squared V over dx squared is equal to m of x. For M1, we have for M1 of x is equal to px1. So EI d squared V1 over dx1 squared is equal to px1. So EI dv1 over dx1 is equal to px1 squared over 2 plus c1. So EI v1 is equal to px1 squared over x plus c1 x1 plus c2. For our m2 of x is equal to pa, we have e of I d squared v over dx2 squared is equal to pa. EI dv2 over dx2 is equal to pax2 plus c3. EI v2 is equal to pax2 squared over 2 plus c3x2 plus c4. So, for boundary conditions, we have v1 is equal to 0 at x is equal to 0. So, from the equation 2, as you can see here, we have c2 is equal to 0. So, due to symmetry, we have dvd2 over dx2 is equal to 0 at x2 is equal to L over 2. So, from equation 3, we have 0 is equal to PAL over 2 plus C3. So our C3 is equal to negative PAL over 2. So for our continuity conditions, V1 is equal to V2 at X1 is equal to X2. So it equal to A. PA3 over 6 plus C1A is equal to PA cubed over 2 minus PA squared L over 2 plus C4. So C1A minus C4 is equal to PA cubed over 3 minus PA squared L over 2. So dV1 over dx1 is equal to dV2 over dx2 at x1 is equal to x2 equal A. PA squared over 2 plus C1 is equal PA squared minus PAL over 2. So our C1 is equal to PA2 over 2 minus PAL over 2. So let's substitute C1 into equation number 5. As you can see here, the number 5, equation number 5. C4 is equal to PA cubed over 6. So dV1 over dxi is equal to P, the A, x1 squared plus A squared minus AL over 2EI. So theta A is equal to dV1 over dx1. X1 is equal to 0. So our PA, A minus L over 2EI. So V1 is equal to Px1 times x1 squared plus 3a times a minus L over 6EI. Our V2, PA times 3x times x minus L plus a squared is over 6EI. So our V max is equal to V2. X is equal to L over 2. So our V2 is equal to PA times 4a squared minus 3l squared over 24EI. For problem 8.9, as we can see, the FBD. So solution. Joint A, tan theta is equal to tan to negative 1, 2 over 1.5. Therefore, the cos theta is equal to 3 over 5. Sin theta is equal to 4 over 5. So, SBE is equal to 20 km. SBC is equal to SBA. So, it is equal to negative 22.5 kN. For SAE, sin theta minus 30 is equal to 0. Therefore, SAE is equal to 30 times 5 over 4. So, 30 times 5 over 4 is equal to 37.5 kN. For our SAB plus SAE cos theta equal to 0. Therefore, our SAB is equal to negative SAE cos theta equal negative 22.5 kN. For SEB plus SEA cos theta 1 plus sec cos plus SEC cos theta 2 is equal to 0. So the SEB is 20 plus the SEA, which is the 37.5, and the cos is 4 over 5. So plus SEC times 4 over 5, the cos is equal to 0. So cancel, then cancel. So our sec SEC is equal to negative 62.5 kN. For SED plus SEC sine theta 2 minus SEA sine theta 1 is equal to 0. SED plus negative 62.5 and the sin is 3 over 5 minus the SEA, which is the 37.5, and copy the sin 3 over 5, so it equal to 0. So cancel. So SED is equal to 60 km. Tan theta 1 is equal to 3/4 times tan theta 2 is equal to 1.5 over 4. So 1.5 over 4 is equal to 3 halves or 3 over 2. Tan theta 1 is equal to 3 over 5. Sin theta 2 is equal to 3 over 5. Cos theta 1 is equal to 4 over 5 and cos theta 2 is equal to 4 over 5. For SAE, sin theta is equal to 1. Therefore, the SAE is equal to 1.25 km. So the SAE cos theta plus the SAB is equal to 0. So therefore, the SAB is equal to negative 0.75 kN. So our SBC is equal to SBA. So it is equal to negative 0.75 km. So the SBE is equal to 0. So the SEA cos theta 1 plus the SEC cos theta 2 is equal to 0. Therefore, the SEC is equal to negative SEA. So it is equal to negative 1.25 km. The SED plus SEC sin theta 2 minus SEA sin theta 1 is equal to 0. So SED minus 1.25 the sin theta 2 the 3/5 minus the SEA which is 1.25 over sin 3 over 5 is equal to 0. So therefore our SED is equal to 1.5 kN. Problem 8.59. Determine slope at A and the vertical displacement at B. Use the method of virtual work EI is constant. As we can see, we have the FBD of problem 8.59. So, calculate the horizontal reaction at point B and take the moment about point A. So the summation of moment of A is equal to 0. B of x times 8 is equal to 60 times 4. So Bx is equal to 30 km. Calculate the horizontal reaction at point A applied to the horizontal equilibrium equations. So the summation of f of x, f of x is equal to 0. Bx plus ax is equal to 60. Ax is equal to 60 minus 30 kN. So Ax is equal to 30 km. So the summation of moment of B is equal to 0. We calculate the vertical reaction of point A. Take the moment about point B. So the summation of moment B is equal to 0. Ay times 3 plus Ax times 8 is equal to 60 times 4. Ay times 3 plus 30 times 8 is equal to 60 times 4. So our Ay is equal to 0. So we calculate the bending moment. So we consider that the section 0 less than x1 less than 4 is MST is equal to AX plus times x1. MST is equal to 30 times x1. So calculate the bending moment of 4 meter from point A. We have mx4 is equal to 30 times 4. So we have 120 kNm. So consider the section 0 less than x1 less than 5. So we have mx2 is equal to a1 ay times 4 plus x2 times 4 over 5. So minus 60 times x2 times 4 over 5. So we have mx2 is equal to 30x. 4 plus x2 times 4 over 5 minus 60 times x2 times 4 over 5. So mx2 is equal to 120 plus 24x2 minus 48 times x2. So our mx2 is equal to 120 minus 24x2. So we calculate the bending moment of 5 meter from point A. We have mx2 is equal to 120 minus 24 times 5. So we have 0 kn m. So here we calculate the slope. So therefore our slope at point A is 260 over EI kn m squared.